Hi, this is Richard C. I'm answering a question submitted by a student. The student is taking trigonometry or precalculus, whatever the course is called at his school or her school. And this is an interesting one because of the way the information is conveyed. So we're interested in the temperature during the day, and we know that every day is 24 hours long, so we know the period is 24. And we're given this point here that at 8 o'clock, the average temperature occurs. So we're told that the minimum is 44 and the maximum is 56. So the average temperature is here at 50. So this is the average temperature. This is the midline. And I like to call this railroad tracks. It's the first thing that I do when I'm doing a graph is I put in my railroad tracks. So this top part is the max, and then the bottom part is the minimum, and then there's the midline. And we're given this point, 8 a.m. It's at the midline. So that's what makes it hard. So the 24 hours, we know that we're going to break this up into 4 pieces, and each piece, each jump is going to be 6 hours long. So if I take the 800 and go back 6, it's at 2 in the morning. And at 2 in the morning, it's going to be at the minimum. If I go forward 6, that's 1400, which is 2 in the afternoon. It's going to be at the maximum. 6 more hours puts me at 20. And then 6 more hours puts me at 26. Now, 26, we're using military time here. But 26 is 2 in the morning. So you can see I now have a curve here. And it's going to, connecting the points, I get a curve that looks like this. And you need to know the shapes of the curves, and this is going to be a negative cosine curve. So the cosine curve typically looks, I always tell my students to think about a vase of flowers. But what we have is it's been reflected over the x-axis, and so it looks like this. Y equals negative cosine x. So we definitely have a y equals negative cosine x. So our function that we're going after is going to be y equals negative a cosine x minus h. Sorry, with a b in front. Plus k. And we have to start filling these pieces in. So we can see, let's start with the period. The period is 24, so 24 is equal to 2 pi over b. So that tells me b is equal to pi over 12. We can see that we have a right shift. We're shifted right 2 hours, so h is going to be 2. And for k, obviously we're up 50 from the origin. The original is symmetric over the origin here. You can see starts and ends like that. This is symmetry. So this is 50 here. And we have A is the amplitude, and you can see the amplitude is 6. So now we can write our equation. It's a little hard to see that green, so I'm just going to change colors. Y is equal to -6 cosine of b, which would be pi over 12 times x minus 6. Oops, not 6. 2 plus 50. And then you just get on your calculator and you set that equal to, they want to know what time you'll hit 48 degrees. So you just set this, you would just go on your calculator, 48. Let's just do it here, -6 cosine pi over 12 x minus 2 plus 50 equals 48. So we can simplify this a little bit, bring over the 50. So that's going to be a -2 here. -6 cosine. And you can divide by -6, so that's going to be 1/3. Okay, so then you can just put into your, if you're using a graphing calculator, y1 would be this cosine. We could have done it anywhere along here, but so y1 is cosine pi over 12 times x minus 2. And you're going to need extra brackets on the calculator. And then you just find the intersection. And so that's how you would finish it on the calculator. I think the hard part here is just getting the, figuring out where the critical points are. And they're giving you one critical point, and they're giving you the period, which is very unusual. So that's what makes the problem so hard. And once you get past that, then it's not so bad. Then it's pretty much similar to everything else you've been seeing in school. Okay, so that's it for today. I hope this was helpful to you, and I'll see you again next time.